We're looking forward to continuing today. So over the course of the next hour, I'm really happy to be joined for some really smart people, make my job easy. We're going to talk about how the automotive ecosystem is evolving. So in the past decades, we've seen what was once an industry really defined by gears and grease move from initiatives around autonomy to electrification to now a focus on what we're seeing driving differentiation around software-defined vehicles. So I guess before we dig any further, I'll first pause, maybe introduce myself. So I'm Chris Rommel. I work at VDC Research. We're a 50-year-old industry analyst and consulting firm focused on the IoT and embedded ecosystem. So as part of that, automotive is a really big part of our focus, looking at everything from hardware components to software and the different tools that engineering organizations use to develop and deploy and manage those different connected systems. And so with that, I'll do a round of introductions here with my esteemed colleagues on the panel. We start with Ray Cornyn.
Hey, good afternoon. So I'm Ray Cornyn from NXP. I look after the advanced automotive processors. I've worked in automotive for about 25 years, so way back to some of the first processors, first safety processors. And my team are working on a new generation of 5-nanometer micros for software-defined vehicles.
Great, thanks. And next, some of you may have heard her earlier today leading a panel. I'm sure she still has a lot of great things to say this afternoon. Junko Yoshida.
Hi, my name is Junko Yoshida. I'm an editor-in-chief of Ojo-Yoshida Report. And as I explained, I retired from EE Times 3 years ago, started my own company with a colleague of mine, ex-colleague of mine, who was the Bolaji Ojo, who was Bloomberg business editor. So our focus is really the business of semiconductors, but we specifically look at the impact of technology on people and societies. That's our shtick. And if you are interested in what we're doing, we actually have it's a little promo here. I'm sorry that I'm just stayed less than 1 minute. If you go out and on the left, there's a QR code. If you use that, you get limited period, you get 50% off of the annual subscription to the Ojo-Yoshida Report. So I hope it's free to register, but if you like it, please subscribe. Thanks.
Great. Thanks. And you, Fang?
All right. Yeah, my name is Fang. I'm from Sonatus. So I'm one of the co-founders at Sonatus, CTO. I lead the product and engineering efforts there. So Sonatus, we are a automotive software company. We help OEMs to accelerate their vehicle software innovations. We have a range of products that we offer to OEMs. Some of them are already on the road today. We're in production with NXP. We're a very close partner with NXP. Very happy to be here.
Great. And then as another repeat offender talking head, Phil Koopman.
Hi, I'm Phil Koopman from Carnegie Mellon University. I've been doing embedded software for, I don't know, 25, 30 years. Depends how you count it, maybe 40. Depends how you count it. I currently teach a course in mission-critical software for embedded systems. I'm high profile on self-driving car safety, but I've actually done safety in a bunch of different domains and all more general. I stopped counting at 200 software design reviews across a ton of domains. So I've done a lot of work in software in the large for embedded systems.
Great, thanks, Phil. So in my 2 decades at VDC, we've seen, I guess, as an industry analyst, a lot of opportunities to create new buzzwords, new terms, new acronyms. So before the edge and IoT, there was an M2M, then connected and embedded was before that. And the automotive industry, as I noted, is somewhat similar. And now there's a whole lot of focus and discussion around SDVs. But around that, I think we need to level set, at least for this conversation, what that means. Because like many things, there can be different interpretations, different meanings behind it. But I do think, regardless, it's really interesting to talk about where the industry is at today versus where it's been. And so with that, maybe I'll start with Ray.
Okay. SDV, probably the most overused term in automotive in about the last 18 months. It covers everything from people believing that getting Angry Birds to run in your infotainment system is the most exciting thing, to actually fully configurable vehicles where you can change the functionality, keep the vehicle evolving as it gets older. And I think that's really what I hope we end up talking about today is that future capability to build a vehicle platform, and then through your ownership, the vehicle continues to develop, and you get more and more capability. So you get more and more longevity out of the vehicle and up-to-date functionality in it.
So, yeah, go ahead, Junko, please. Yeah.
Oh, okay. Well, I don't know anything. I'm just I just write about what people tell me. Yeah. But the thing that really, I think 5 years ago, when you hear anything about over-the-air updates or software-defined vehicle, the first thing most journalists, including myself, thought, oh, this is like smartphones on a wheel, right? So it's like just like smartphone. There's an application processor. You can download the app, and then you can have this great games or whatever. That was the original idea. And it took all of us for a long time really what software-defined vehicle is, because as Ray said, it actually permeates throughout the vehicle. I didn't really appreciate the complexity involved in software-defined vehicle. Yeah.
So I think what's really interesting too is when you think about that software definition extending beyond the vehicle itself, not even to the in-vehicle networks, but all the infrastructure that's required to help support that next level functionality that we're all envisioning for the future. And I'd be interested to hear your perspective on the term, the industry at large, given your organization.
Yes, so one of the interesting things is that when we started Sonatus in 2018, SDV was not a widely used term at that time. But at that time, we had a vision about what we want to allow OEM to be able to do with their vehicles, right? So at the more fundamental level, we want to basically allow OEMs to, gain deep visibility into their vehicles, what's happening with their vehicle, and how their customers are using those vehicles, right, in the real world. And then being able to use that information to gain insight about how to improve their products, right? How to bring new user experience to their customers. And then being able to very quickly deploy those new features, new services back into their vehicle or to their customer, and be able to do this continuously throughout the life cycle of the vehicle, right? So that's really what we want to enable the OEM be able to do, right? At higher level, I think it's really software-defined vehicle. We hope that will bring OEM unprecedented flexibility, extensibility, and scalability to their business and their products.
Yeah, I think that's really important to note that it's beyond just being a connected car, right? In terms of what we're talking about, the transformation that we're seeing a lot of OEMs go through. And actually, Phil, I'd be interested in your take on that, given some of the experiences you talked about briefly earlier this morning about where things have come and some of the first experimentations around autonomy that you were involved in, to how you think about SDVs and what they are today, and I guess what they are not.
Okay, well, I said in the previous session that this has been going on for 25 years, right? And it's a continuing journey. And having the car connected to the outside world allows a lot better data capture and continuous improvement, all those things. There's some life cycle concerns to be sure. Let me go some different way to build I think Junko said, a cell phone on wheels, right?
Yeah.
Well, you can say cell phone crash and you can say car crash. And they're kind of the same words, but they kind of have different implications, right?
Yeah.
And this is really important. It's actually a lot deeper than you might think, because what happens is as soon as you allow software to influence the behavior of the vehicle in any way, which for SDV, that's kind of the point, right? Now, all this infrastructure, all this stuff that didn't used to be a big deal, all of a sudden becomes life critical. So if your autonomous vehicle is safe because you have completely accurate high-definition maps that are updated, well, that entire data pipeline just became life critical. Your cloud server all of a sudden is a matter of life and death, and it didn't used to be. And a lot of folks aren't really thinking about it that way. But if you get a bad map update and it drives you onto railroad tracks or drives you in a river, which people do that because maps and they're not paying attention. But now you have a car that says, that's a roadway, okay, I'll get on it, and you're going down a railroad track. That's going to be a problem. So there's a lot of implications for safety. You can get these cool features, but the other side of the same coin is you're invoking safety in a lot of things that it didn't used to be as big a deal.
Yeah, so I guess to that end then, Phil, I mean, how do you see this interplay of having a vehicle as a platform with that continuous functionality, and data being driven from it, as you was discussing as well, in this, I guess, against these trends where you're trying to consolidate systems, have mixed criticality as the, in some cases, a basis for some of the software definition, whether it's using software partitions or hardware partitions. Obviously, there's architectures are fundamentally changing and bringing with it, to your point, a lot of additional considerations around safety.
Well, a classic thing in safety is you don't mix ordinary quality software with safety critical software. The ordinary quality software can interfere with the safety critical software. You're going to have a bad outcome eventually. And so putting them on the same platform means you better have some smart isolation. But it's more than that, because the safety software may be tempted to use data fed from the untrusted software that tricks it to do it in something that's unsafe. I think every single architecture I've ever looked at that was fresh, that was in there somewhere, right? Yeah. This is and all my safety colleagues say the same thing. So there's a lot of challenges because it's easy to provide cool features and sort of miss the implications for safety, right? So that's going to be an issue. Now, of course, you can do cool stuff, but the question is, do we keep doing safety the way we have been with this hardcore isolation, or do we develop something else that allows us to relax that? The argument for relaxing it is money and time to market, but I've never heard a safety argument that safety will be improved by doing this. So anytime someone wants to relax the isolation, you got to ask the safety question. And if they have a story to tell, that's cool, but they need to have a story other than it'll be fine.
Yeah. I guess as we think about this transition to more zonal architectures away from the, I guess, potential redundancy and physically discrete ECU architecture of the past, I mean, Ray, what are you seeing in terms of the ecosystem at large and how it's changing around this fundamental shift in how these vehicles are made?
Yeah, I mean, it's quite interesting that you're now looking at platforms. For most of the traditional vehicle today, you have an ECU which comes with software that will be a combination of probably a tier one and an OEM. And now what you're looking at is these integration platforms which will have multi-applications running on with software from many, many different sources. So you're now going to have people who previously built an ECU maybe just becoming a software provider, or people who haven't ever written software before now providing part of the application. And so a lot of that is driving requirements and isolation and architectures to try and protect, as you say, safe code from, well, I hate to use the term unsafe code, but just keeping functions isolated. And I think when the first work on SDV kind of started, there was this view of, well, we'll just throw a really big apps processor at it, and as you say, there'll be enough functionality, there'll be enough CPU performance that we'll be able to make it work. And clearly that didn't happen, because people tried it. They threw these multi-gigahertz processors at these applications, and instead of getting gigahertz performance, they discovered the same performance as a 100 megahertz microcontroller from 10 years ago. So, fundamentally, the ecosystem and the architecture is going to have to change to get efficient capability in there. Yeah.
Junko, as a longtime industry observer, I mean, what have you seen in the different ways that organizations are positioning themselves around this?
Yeah.
And I guess they followed through with how they're trying to change their business prospects.
Well, as with every business, every company has its own angle, right? Yeah. It's a little self-serving, but they've got their angle. And if you're in the in-vehicle networking automotive Ethernet market, of course you want to say that our automotive Ethernet market will enable a software-defined vehicle. And of course, if you are the big so-called brain chip that does everything, they say that this is the way of the future, this is the way the roadmap is going. That's how they place it. But until I recently talked to Ray, I have to say that I was so ignorant. I didn't realize, because I don't actually open up the so-called central compute engine box in a vehicle, I used to think there was one chip in there. Because, you go to the CES, you get on the self-driving car demo, and then they, it seems like they have a huge things in the trunk. But other than that, I thought that there's a one chip, like the big NVIDIA's chip is inside in the so-called central compute engine. And Ray was telling me that, no, Junko, it's not just one chip. It could be 2 chips. It could be 3 chips. It could be more chips. Really? Did I actually get? This is like how superficial understanding most of the media have, because we haven't seen it. We thought that it's just one chip, right? So that changes everything. That actually changes everything, the way we think about what is the central compute. Because central compute, going back to the analogy of smartphone and wheel, we think there's one, Snapdragon application processor inside that does everything, right? But it turns out it's not. So I think it's software-defined vehicle really needs to be explained in much more, I wouldn't say detail, but it's a very different architecture than I thought that I had understood. Yeah.
And I'd be interested to hear a little bit about how you thought, I guess, get the initial idea for Sonatus. Because obviously we're talking about how the ecosystem is changing, and the positioning of your company is such that it's solving a problem that really wasn't there 10, 15 years ago at scale.
Well, it's not that the problem was not there. The problem was there, but not many people were thinking about, what's the best way to solve that problem, right? So, me and my co-founder, we came from data center world, and we have been developing technologies and solutions around building, highly scalable, very high performant and reliable data center, right? And there are a lot of software-defined technologies that have been developed for that kind of environment. And looking at what the vehicle needs to have, right? So we realized that actually a lot of the solutions that used to be applied to data center actually could be applied to the vehicle itself, right? We talk about architecture, right? So before, the vehicle architecture is very much distributed and fragmented, right? Which is a huge challenge to OEMs when they try to inject more software, more flexibility into their vehicles, right? But if you look at the kind of architecture that's available in a data center, right? It is supported by a very powerful network, right? That's what you have at the very bottom. And then on top of that, you have a set of compute resources and storage resources that are managed in a way that it's very flexible, right? You can run your application in any one of those compute resource, and you can store the data in any of the storage resource, and different application can share those data, right? So all that has already been realized in the data center environment, right? So the same can be done for the vehicle, right? So therefore, we do believe that architecture can make a big difference, right? But we also realize that making this kind of architecture shift is not easy for OEMs, right? So you have a lot of legacy solutions, components, right? You cannot replace overnight. And there is cost associated with new technology adoption. So it has to be a gradual transition, right? So we also realize that. Yeah. So therefore, we intentionally build our solution in a way that it can help OEMs to make that transition, right? So they don't have to jump from this extreme to that extreme, right? They can make that transition as they feel comfortable. And that's also where we had a very good collaboration with NXP, because NXP also provides a range of products that caters to, right, all different kind of architecture. And so therefore, we're able to combine our solutions and really enable the OEMs to make that transition.
Yeah, can I just go?
Yeah, please.
Because one of the things we realized quite quickly from our discussions with OEMs is that there wasn't going to be a single answer. There was a whole number of steps along the SDV road that people would take, and everybody might have their idea in that long term, big central compute with multiple different processors, small smart actuation round the side. But it takes, when you come from a background of today's vehicles, that's a very big step to make. Now, the interesting to watch is some of the new Chinese startup companies, because they don't have that legacy, so they can make big jumps ahead. So we see some of those guys getting to market with new ideas very quickly. But you do have to recognize that other car companies, especially the ones with very large portfolios, have to make a number of steps to get there. And so, as you say, our philosophy has been, a range of different kind of processing steps that will let people design the level of SDV that they want, but always still recognizing where the end game should be. So yeah, that's been part of the philosophy. Yeah.
So I'd say that regardless of where OEMs are in their journey transition towards SDV, understanding that their lineage or their legacy assets dictates a lot of how quickly or how agile they can move. The fundamental underlying, I guess, common theme is the fact that software development is changing and is becoming vastly more important. And even heard in one of the sessions earlier today, NXP now has more software engineers than hardware engineers, which I think is huge evidence of what's happening in this ecosystem at large. And as actually in some research I just conducted on a survey of automotive engineers, 50% of them said that they expect for their next project, their internally developed lines of code to grow over 50%. So if you think about the resource constraints many these organizations have, the difficulty they have scaling quickly, especially these large multinational organizations, you can understand how that can place a lot of additional stress on those organizations. Phil, I'd be interested in your take on how you see SDVs or software development changing as a function of this SDV movement, and I guess the maybe pitfalls along the way.
That's like an hour lecture, which I promise not to give. But let me address architecture and segue in. And if I get lost, you can put me back on course. I've been doing distributed architecture since 1980, I think. And I've seen it in a bunch of different environments and industries. And the thing is, the people with centralized architecture have distributed architecture envy. And the people with distributed architecture have centralized architecture envy. And it's a pendulum that swings back and forth. Yeah. You can see it in various environments, right? And I've done a lot of consulting where people say, we're centralized, clearly distributed is better, right? Prove us right. And then another company the next year will be, we're centralized, or we're distributed, I'm sure centralized. Yeah, and the answer is always, it's a wash and it all depends on other factors because there's pros and cons. And somewhere in my archived lectures, actually I have an hour-long lecture on the pros and cons. And the pros and cons always never boil down to BOM cost. You want them to, but they never do, okay? Because the enclosures for distributed outweigh the savings, right? But what the architecture does do is it reflects the organization. That's Conway's law, right? The architecture reflects the organization and the supply chain in particular for the car companies. So the car companies want to capture more of the value by grabbing hold of the software and centralizing it and building up their soft. See, I actually got back on the topic. And go back to the, capture the value by having their in-house software. They have two issues. One is that has to match their hardware architecture, right? But the other is their organization has to change fundamentally because they can't, if there's a software compatibility issue, they can't go beat on the suppliers like they do now to fix it. They got to own that problem. So it's technical, it's architectural, it's technical skills because the OEMs historically don't have the strong skills they're going to need for that level of software. But it's also how the organization maps onto the architecture, onto the skills. So it's a really complicated problem. And I know everyone wants to adopt it slowly and gradually, but the slow, gradual path is seldom the most efficient path. So you have to sort of figure all that out. And there's no easy answers here, right?
Yeah. So I think it's important to go back to your comment earlier, too, that at the end of the day, these vehicles, as connected as they might be, as software-defined as they might be, and throwing aside buzzwords like enterprise on wheels or cell phone wheels or otherwise, they are still safety-critical systems. And that brings with it additional considerations around software development process standards, and we're really getting to the domain of software engineering versus coding. And you, as someone coming from the enterprise side, I'd be interested in your thoughts on that interplay in this safety-critical industry.
Right. So, so definitely on one hand, I think automotive industry is very unique, right, in its requirement around safety and also its approach to safety. I think it's very different from pretty much all other verticals. However, on the other hand, in the end of the day, it's all about the quality, reliability of your system, right? That includes your hardware and your software, right, coming together and being work really well for serve whatever customer needs, right? That particular requirement actually is not unique to the automotive world. You can argue in some other verticals like banking system, right? We used to sell products into banks, right? Very, very sensitive information stored, and you cannot tolerate any kind of faults or errors and things like that, right? So even though their approach to safety is very different, however, the requirement is the same, right? So therefore, we actually look more at software development practice, right? How you can define a process to when you develop your software that makes sure your software is both safe and secure, right? So that starts from laying down a very good architecture to doing the right kind of partitioning, and then doing individual module design, defining a good interface across different modules, and doing all kinds of testing, right? Different levels of testing, unit test, integration test, bench test, vehicle test, the whole 9 yards. So really, follow a very well-defined process to ensure, right, your software is safe, is secure. That's the most important part. So what makes it a little bit more challenging nowadays with the consolidation of software into common hardware platform is that now you have more than one software companies, right, offering products that needs to work together in a way that is seamless, that is reliable. And a lot of time they do share data, right, or service, right? Everybody's talking about service-oriented architecture, so they have to share, right? So how do you make sure individually maybe they're all very solid, but now when they come together, can you still make sure everything is solid and safe, right? Before, there's not a very good way to look at that, right? Everybody's say, oh, I can safety certify my software. I'm going to make a million assumptions about other software around me, right? But nobody's checking those assumptions, whether or not they're real or not, right? So there's new challenges when we're talking about system level testing, especially in the software-defined vehicle environment.
Yeah. So Ray, how do you see that role of the common hardware platform that you mentioned, like interplay against the discussion we had earlier today around stretching right with these organizations beyond, people have been talking about shifting left for a long time for development efficiency purposes, but now with these software-defined vehicles that people want functionality to evolve, there's a new avenue for differentiation for these organizations for these non-static functionality.
Yeah. I think one of the, and it's interesting from what you were saying about, the development in terms of a safe and secure environment, in terms of how that can develop and evolve into those additional features. Because what's starting to happen is that the car companies are trying to do a lot in a virtual environment. Previously a lot of software in the automotive industry was put on test vehicles and pushed out into a fleet to test. And every car had a big red button on it in case something went wrong and you hit the big red button. But now what they're evolving into is running what's commonly, again an overused term, running digital twins. So they'll run a model of the vehicle and then test it against real data from kind of like big data coming in from all the connected vehicles. And that then allows them to try out new pieces of software. So you can try out a piece of software in the background. You maybe actually test some of it out in the fleet, and that allows you to bring in new features and have them thoroughly tested before that you then decide to roll them out through OTA. And that allows you this additional functionality in the stretch right, where you can keep adding functionality. Because I think one of the things the industry has to go over, the very first experience of OTA have not been great in the industry. There have been a number of bricking of modules and bricking of vehicles, which really, if people are going to be confident in this as a new development philosophy, and they're willing to pay for all these additional features, they're going to have to know that once they put that new feature on, the rest of the car is still going to work around there. So the only way for the industry to do that is through huge amounts of simulation and testing, using real data that they're pulling in. And there's a lot of investment going on in the industry to make that happen. So I think that's one of the big changes. And I think it's got a very good path to success. Yeah.
And Junko,
Yeah.
given some of these trends, we mentioned some of the, I guess, needed places of investment that everyone was speaking about there. I'd be interested in your take on what you're seeing as any expertise gaps emerging in the ecosystem based on where it's coming from, even acknowledging it's been a gradual transition over decades. In some ways, some of these things, they're concavity shifts in the way these organizations are functioning.
Things that I hadn't really thought about, and recently I suddenly was told, and I realized, I started to digest, was that, we all talk about software, right? And how the software, what used to, software that was in one little ECU is now being absorbed, sucked into another, domain controller or zonal controller or central. But I think what's also happening is that if there's a central, if there's a lot of processing powers available, that you can actually distribute the processing power, distribute the memory, you can actually, this little zonal controller says, hey, I'd like to have a little processor here, please, and you share it, right? That's part of the software that it didn't really, and that's really the part of the architectural discussion, I think, because software, you always, as a consumer, I always think about software as an application, but it's not, right? So that's a gap that I really didn't understand, but I'm not sure, what implication it has. For example, NXP has probably industry's best block diagram to describe what the current vehicle model is with all those ECUs, and then next level is domain controller. And then next level is a zonal controller, and then central. It's the best, block diagrams, and I use them over and over every time when I write something, so people need to understand what is zonal, what is a domain, and yet things are not that simple, right?
No, that's as simplified as we can draw it.
Yeah, right. I mean, it's like, as a reporter, I'd like a simple story because it's a clear, clear-cut story. But in fact, there's a mix. Yeah, I mean, I can't imagine how hard would that be for your automotive companies or the companies like NXP serving the automotive industry. How do you do that? It's very complex. I mean, it's just not a straight roadmap.
Yeah, and it was when we started to see, the change from individual ECUs into this upward integration, and then all the different versions. It was one of the things that a few years ago, we decided to build a common architecture that we would use across from microcontrollers all the way up to our high-end processors, because we knew that functions were going to start moving around, and it would be easier if we had a common software base and a common architecture. So even if it's a small micro, it uses the same fundamental security system as the high-end system, and we would be able to accommodate customers who wanted to move functions from one area to another.
You can reuse.
Yeah, so the software would become reusable. And it was at the time we were doing it, it was a big investment because we'd lots of different little architectures, and it was no. If the industry is going to go that way, we have to get to that standard. But yeah, you're right. The diagrams are complicated. That diagram you talk about, I know that one I use that one all the time. I know you use it. But
that's the best diagram.
It is a much simplified version of the reality that's out there.
Yeah.
I think that's a good comment. I must thank I'm trying to remember which of the guys in my team wrote that diagram. I think it's Brian Carrollson, actually, if he's out there.
So most people don't like working with lawyers, but Phil, you mentioned earlier today that you've been working closely with one and helping to think about ethics and the role in the industry. Specifically as it pertains to safety critical functionality and such, what are some other areas that you see that are other areas needing investment or other skills that OEMs maybe don't have? I mean, certainly many of them are litigious in how they look at the industry and how they operate, but are there any other areas outside of just new system architecture or engineering principles that you think they need to embrace or think about as SDVs continue to evolve?
So where to begin? Okay. So let me start by keying on something you said a while back. With this many panelists, sometimes things go by.
Yeah.
Well, I'm going to go back because you hit one of my soapboxes, so everyone's going to get a 30-second rant, but I promise to limit it, okay? Like, the worst thing that happened to software quality in the last 10 years is the concept that coding boot camp makes you a software engineer. You know, if you learn, it's like saying, hey, I taught you how to use a hammer and how to use a saw. You're a building architect. Does that make sense? Yeah. Well, why does writing lines of code make you a system architect? It doesn't. It's a skill. You know, learning how to put together a sentence doesn't make you a novelist. Trust me. Okay. And so now that doesn't mean teaching people how to code is bad. But I spent a lot of my professional career undoing all the harm that was done by teaching people coding as the end instead of the means, right? So from a skill point of view, when I look at what there's a bunch of car companies have to reskill, and I talked to some of these. And it's not so hard for them to get courses on higher level software architectures and AutoSAR and tools and that stuff. There's vendors trying to sell you something, you can get courses on it, right? The place where they struggle is partly classical embedded system skills. Just how to use an analog to digital conversion other than here's my Arduino, call this library, right? Yeah. How actually this stuff works down at the bare metal level, that's part of it. But a lot of it is system engineering, just dealing with this complexity we're talking about, right? And a lot of the OEMs are not at all prepared to staff system engineers. So we did a benchmark across a bunch of companies, not just automotive, that had successful and unsuccessful projects. And where we came out was the system plus safety engineering has to be about 10% of the effort for something as complicated as a car, right? And out of that 10%, it's 2.5 safety and 7.5 integration system engineering. There's just like a standard number that below that, you're gonna have problems, and at that, it's probably okay. And you see companies staffing it at 1%. Well, you know what? They're gonna have problems. And training system engineers is no small thing. So coming up with a system perspective, interdisciplinary, embedded, because it isn't just software, right? It's a lot of interdisciplinary. Those are the two areas I see as most in need of improvement. And the managers to appreciate, well, it's just a bunch of system engineers. They're just putting requirements through doors. What's the problem, right? That's only a piece of it. And they're not writing code, so where's the value? Well, the value you're going to find out when. Wasn't there a CEO who just got fired over his software quality? Yeah. Just saying. Not criticizing that company. He's just the one who happened to get fired.
Yeah. So it's interesting because the automotive industry is one in which a third of projects are already late, right? And we're talking about this transition where there's more complexity and fundamental changes in the way that they want to bring products to market, which challenges the status quo and makes it even harder to be successful. And that's on top of any claims or self-certification, self-proclamations of expertise in carpentry or otherwise for skills in embedded systems or systems of systems engineering. So I'd be interested in your take, given the inflection point we might be from organizations to reevaluate their own skills, what are things that you see automotive organizations doing that are self-sabotaging themselves based on where they are today, but more specifically, what they need to contend with 10, 15 years down the line if they want to be able to leverage any of that IP and work that they're investing in today?
Yeah, so maybe I'll answer the question from the angle of what we think that will really benefit OEMs, right? What they can do. So one is probably there are some fundamental technologies that on the surface, it may look straightforward, but you don't want to underestimate the amount of complexity in terms of really implementing and taking advantage of it. So networking is one of such examples, right? On the surface, it looks pretty straightforward. You can shuffle bits and packets around, right? However, there's much more to it than that because nowadays you have so many different types of traffic running around your vehicles. Some of them are safety critical. Some of them are not. Some of them are low bandwidth, but very sensitive to latency. Some of them are high bandwidth, but less sensitive to latency, right? And you have all of those type of traffic running on the same network because you want to save cost, right? And then you bring in your zonal architecture. Now you have even more mixture of traffic on the same network, right? So how do you make sure each of those traffic can meet their own requirement, right, without affecting each other. Non-trivial problem to solve, right? And you can actually do more if you have the right network or the right software to manage your network, because not only you can control the traffic, now you can actually access the traffic that's flowing around on your network. So therefore, like our data collection solution actually leverage that particular attribute that we try to get data from the network as much as possible, so you don't have to get into the particular ECUs to get the information, which is much more difficult, right? And talking about security, right? If you want to do intrusion detection, that also means that you need to have visibility into a lot of the activities that's going around in your vehicle. You can plant software everywhere in every ECU, but that's very expensive. But rather, if you watch over what's happening in your network, you can get a pretty good idea of what's happening, right? So there are a lot of things you can do to benefit from that. So that's one. Second, I think OEMs, even though they have certain solutions today, I think they probably want to think whether there's more that can be done, right? For example, OTA is such an example, right? Traditionally, you can do software update, firmware update, and so on and so forth. But at this point, one challenge to OEM is the cost of doing such OTAs, right? Especially if you want to do it very frequently, right? And two is sometimes the update is not only the software, but non-software things also needs to be updated, like configuration, right? So you have a mixture of assets, right? Before, it's very singular assets. You have like Android image, you just update that, you're done. But nowadays, you're talking about, you want to enable an application, like say, battery management system, right? You want to enable that application to be able to leverage some of your, transmission information in order to have better prediction of your battery life. And how do you make that information available to your battery management software, right? So it's not just about updating, the ECU software. There's, like say, network in the middle, and how do you reconfigure it, and so on and so forth. So they need to look at that and asking, okay, what other better tools I need in order to do the OTA. And third is, maybe ask the question of, okay, are there alternative ways of doing, what I used to do with OTA, for example, without all the burden and cost of OTA, right? So recently, we launched a product we called Automotive, right? Which is giving an alternative, right? Not to, like say, completely remove the need of OTA, which you still need, but give them another very powerful tool where they can do updates to their vehicles without touching any of the software in the vehicle, right? Yeah. So we call it codeless update. So it just adds more capabilities to their toolbox, right? That allow them to do things better and faster.
If I can revisit the architecture points.
Please.
Summing up some of what, all the cool stuff you said. Let's go back to the high level. If you have a centralized architecture, you gain flexibility, but at the cost of system integration complexity, because everything can interfere with everything else. Yeah. If you go to a distributed architecture, and how distributed is an interesting question, but once you distribute, you're managing the system easier if you're smart about how you distribute. And classically, okay, Bosch, you're going to build this box, and Conti, you're going to build this one, and Magna, you're going to build this one, and all the other ones I didn't name. They each get a box, right? Yep. But that's the organization. It helps you manage it. But the problem is you're dragging potentially all these high bandwidth, low latency data feeds out on the networks between the boxes, right? And so what I said before, there's no free lunch. That's sort of an example of why there's no free lunch. There's cost both ways. You have to optimize for what you're after. But it's all about, if you slice the architecture up right, life is good. And if you slice it up wrong, there's no recovering from that.
So Junko, what do you see as some of those other pitfalls automotive engineering organizations might be making as they're thinking about the future, or rather their current actions versus what might come?
Yeah, this was actually explained to me. This is not so technical. This is more of a, business questions, I think. I think Phil Umsrud was telling me that when I was interviewing him, he said, what happens is that I think Phil also mentioned this, that if you actually take all the responsibilities of software updates via central compute engine, it's not going to be tier ones.
it's going to be on you. OEMs have to take responsibilities when something has gone wrong, right? I mean, it used to, the business model in the automotive industry used to be like OEMs can always call, Conti. There's some problems and his car is stuck on highway and call up Conti. You get in there and fix it. I don't care whether it's a software problem, hardware problem, you fix it. OEM was able to make that call. Now, if it is OEM who designed the central compute engine, who do you call? Right? And that's a huge business model change. And I don't think that a lot of OEMs have really thought through what they're getting into.
So Junko, you're saying if they want to profit from integration, they actually have to own it.
Oh, own it. Yeah, and that's it's a good news, bad news thing, right? It's a huge responsibility.
Yeah. And then one of the other sides that they also, as part of that responsibility, is they're going to be using code from multiple sources, and that code is private to those multiple sources. So they then have to own the security, and we're now talking about security and IP rights and code, and they have to manage that, and maybe they decide to have a system integrator. So they're then going to have to handle all the security of their own code. So it's quite a challenge. I mean, but let's not, the OEMs are thinking about this stuff. They understand, they see the problem in front of them, but they see the benefits they can gain from it, because they've lived the life of the last 10 years, of 20 years of, I've got 80 ECUs in my car, I've got this idea for a new function, it doesn't fit in any of them. And they look at value propositions, things that they know they could make more profit from, their customers would love. And just in today's architecture, there isn't anything in a 10-year-old architecture that is easy to update. But if you use some of the more modern architectures, you then get that value proposition opens up to them. So they understand the risks, but they also see the benefits long term, and that's why there is so much investment getting in at this time.
So it's interesting your point, bring up third-party software content and such, because in many ways, it could be actually fourth or fifth-party code, depending upon how far that chain of obfuscation happens through the supply chain. And it's one thing to try to utilize binary analysis or other SCA tactics to try to get a handle on it, but it's still really a black box where you're not have the same transparency or the institutional knowledge of what all of those code assets are.
But one of the things, and a lot of the work on like the new processor architectures are to make sure that those isolation barriers take care. Because we had a discussion a couple of days ago about, in the auto industry, there is still some horrible old code from 15, 20 years ago, which is normally called spaghetti code, right? And it was written by two engineers in the late 1990s, and no one quite, the only thing they know is that it works. They don't quite know how it works. But,
It kind of works. And safety kind of works.
It's safety, but people still want, so if you're going to use these new architectures, they're going to have to be able to say, right, we know this isn't a very good piece of code, but we can keep it isolated in this domain. And there's a lot of hardware work and a lot of safety architecture work to do to make that happen. And that is getting worked on at the moment, definitely.
So beyond the stickiness of spaghetti code and the practices around that, not that any of your customers would do anything wrong. I mean, do you see any?
Of course not.
No. Do you see anything else in terms of mistakes they should make or new technologies they should invest in as they look forward?
I think the investment on the development tools that they will use and the software analysis tools, it's funny, I don't think they can spend enough money. I think that is what, because the analysis, being able to profile code, being able to understand exactly how your networks work, are the things that are going to give them the best time to market. But it's always hard. I mean, I've worked in engineering companies for years. That's a big investment to make. But the fall through from that investment will be superb for them. But that's one thing. I think if you don't put enough investment, you don't, as you said, have the right software. If you just go and, there's a lot of software skills out there that are, as you said, it's just right. I'll just sit here and write code. You need the system architects, and you need to invest in the tools that they're getting to use. And then I think that's not doing that is, I think, the thing that could trip up a few companies.
Well, NXP and Freesco have a long history of understanding the importance of software and tools, whether or not you're looking at Metalworks, MQX, some of those investments.
Wow, you remember a long time ago, you remember Metalworks.
But I guess beyond that, I think this discussion has really highlighted the value and importance of an ecosystem, and how today, more than ever, in order to achieve some of those goals, it's important to have that ecosystem to afford your organization the flexibility to leverage those assets and that IP you're developing now. I mean, Junko, do you see any other areas you think organizations should be investing in today? Are there new technologies that you've seen emerge through your coverage that are important to the future of the SDV ecosystem?
I think tools are definitely missing, right? They don't. You can't really blame engineers if they don't have good tools. But one of the things this is one of my soapboxes. Every time when I interview companies, whether chip companies or system companies or the tier ones, they always brag about how many software engineers they have. What difference does it make? I mean, they want to say, oh yeah, Junko, 80% of our organization, all software engineers. Well, it's good for you, but it's like, what? I think that our conversation in assessing the company's ability to keep up with the modern architecture is still stuck in how many software engineers do you have? And I think we have to get over that, and the companies need to be able to explain better. How they actually, it's just a number of heads.
Well, that ultimately makes it why tooling is so much more important,
Exactly.
right? To drive that efficiency and automation to a level which, any changes in human resources can't necessarily accommodate. I mentioned before the growth we're seeing in just software content being created at these OEMs, let alone, tier ones, tier twos, and, third-party ecosystem, all of which trying to develop content for the automotive industry. I mean, Phil, do you see any other types of technologies that you think is a lasting thought the audience should take with them and that they should be looking at or thinking about and as the ecosystem moves forward?
Well, there's a good rule of thumb to see how mature your tool support is. Look at what fraction of all your work products are spreadsheets. So hear the chuckle? Did you hear the chuckles, right? Just saying, right? So there's that, but also, Junko said they brag about their software engineers. What they mean is coders.
Yeah,
Right?
exactly.
And that's,
yeah.
really, we're getting back to, you can't code up a safe car. You have to actually engineer it, right? And the degree is a little predictive, not that predictive, because domain experts can write really good software, really bad software. It's a question of whether they treat software creation as a discipline worthy of respect, as opposed to anyone can write code, just get the code written, because if you treat it with respect, just like, I mean, would you like to have a nuclear power plant designed by a guy who learned how to weld? I think not, right? And so software needs to be treated as a first-class citizen in the organization and not just coding. I think we can change that culture, and with it, conformance to safety standards, things like this. I think that would go a long way, and it's going to be a while before the car industry sort of makes that transition all the way. Some companies faster than others.
And do you have any lasting words of wisdom for the people attending today's session on areas you think are important for them to watch or invest in going forward?
Yeah, so I think I want to make one comment about the tool discussion and maybe slightly different angle looking at that. Of course, one way to look at it is you need a whole set of new tools to help you develop your software-defined vehicle in a way that's much more efficient. But on the other hand, maybe OEM can also think about how to do more with their vehicles, right? Instead of relying on a lot of extra tools, for example, if you're doing ADAS, you have a full trunk of equipment that you need to collect, the data, which is still not enough, right, to train your algorithm. Can you use your vehicle and the software that's already in your vehicle to do that for you in the real world as real people driving your car around? And also for testing, right? Can you just use your vehicle to do the testing by itself without the need of third-party equipment, and without the need of your test engineer right next to the vehicle, right? Can you do that? It is possible, right? Today with some of the technology and also some of the product that we're offering, it is possible, right? So to some extent, it's almost like OEMs probably, we want them to have even higher expectation about the suppliers, right? We want them to think big, really, really big. right? Because that's really what we as a supplier wants to do, is to really bring cutting edge solutions to help them to achieve whatever goal they have, right? So yeah, so we actually want them to think big.
So one thing that's become clear to me over the discussion in the panel, but also in the sessions earlier, is that different organizations are at very different points in their maturation and their evolution towards SDV, and as well as what they believe is right. Right, given your experience, what do you think are the best practices for organizations to help accelerate that transformation or learning as they're on that journey? And I guess specifically, working with NXP. So
in terms of the kind of best practices, it is, and I think I said this earlier, it's to know the end game. So, and because the worst thing to do is just to take iterative steps that really are taking you nowhere. And you do see that because it's economically easier to justify to your management, I'm just going to do this. I'll upgrade this ECU, don't worry, it will give it some new functionality. I think that's some of the missteps that can take place. But if the car companies and the tools vendors who have a long-term plan of where things should go and they make the right steps, I think that's the road to success, definitely. Yeah.
Great, thanks. Well, we're just about out of time, so I want to thank you all for your attention and thank my esteemed panelists here for your help and guiding the discussion today. This has been great. Thank you.
Okay. Thank you.
Thank you.